Hello all, we will be discussing on flip-flops today. So our aim is to develop the Verilog code for the flip-flops. So in the upcoming videos we will be discussing with respect to SR, D and T flip-flop. Today we will be discussing with respect to JK flip-flop. So the first, I think you already know about the JK flip-flop. So the input pins are J and K, and similarly we have a reset button here, and then a clock which is given, and for this we'll be using a positive clock pulses, and then the output will be our Q and Q bar, that is QB. The truth table is as shown here. So the input pins, as I've told, reset, clock, JK, and the output pins are Q and QB, and similarly you can see the action here, what will happen. So the clock pulse will always be high here, and the JK, these are the inputs which we are going to change. So for 0 0 JK input, so irrespectively, so whatever the output state will be there, the same will be retained, so that is no change state. Similarly, if we have 0 and 1, then it is reset, so it will be having 0 and 1 itself. So if JK is 1 and 0, then Q and Q bar will be 1 0, so that is set input, we call it as a set input. Then similarly, if a JK is 1 and 1, it is called as Q and Q bar, that is nothing but the toggle state of the JK flip-flop. Similarly, let us go with the code here, the Verilog code which we are using here. So first, the module which I have taken here, it is JK flip-flop, so where JK is the input, clock, reset is the input, all these three, and Q and Q bar is the output. So you can see the input, so J and K, which is declared, and similarly reset and clock is also declared as the input, and the output Q and Q bar is taken here. So here always at the positive edge of the clock, as I've told here, so clock will always be positive, right? So for the positive edge of the clock, this following procedure will begin. So if the reset pin is equal to 1, then Q is equal to 0 and Q bar is equal to 1. If not, we will get into the else part, so that is the case 2. So this is 2 bit which is defined for 0 0 0 1 1 0 and 1 1, which is here, which we needed to declare the inputs, right? 0 0 0 1 1 0 1 1. So we are declaring it like this: 2 bit 0 0 begin. So this is the condition case in which we are writing in the Verilog code. So Q, if it is 0 0, we know that Q is equal to Q itself and QB itself, QB. That means it is a no change state. Similarly, if it is 0 1, we know that Q equal to 0 and QB equal to 1. That is the reset state. If it is 1 0, then Q equal to 1, QB equal to 0. That is the set state. Similarly, if both are equal to 1, that is JK is 1, then our output will be equal to the toggle of the input. So whatever the previous state was there, so it will be the toggling state. So this would be end of our program. So by default, we're going to end everything. So begin, we have started here, right? So we're going to end it. Similarly, end case and the end module. So let us see the execution of the program here. So we are using Xylene X ISE IDE for this. So I have written the same code here, and first we have to check the syntax is proper, and then we can view the RTL schematic also here. This is the RTL, so the same as I've shown here, right? This one. So the same thing you can see here, JK, clock, reset, the input pins, and Q and Q bar. So that means whatever our program which we have written, that is proper, right? Similarly, if you want, you can check the technical schematic also. If not, no needed. Then we will go with the sources here. This was the file name, right? So now what I have to do, I need to check this, right? For that I have to add a test bench. For that, so you need to go with the new source, then add a test bench waveform, give it a name, and then add it here. I've already added the test bench here. Okay, so in order to go with the test bench waveform, so we have to change this implementation to behavioral simulation, right? So as I've told, I've already added the test bench here, so which you can see here. The name I have given is test. So if I would click on this and select the simulate behavioral model, right? So you can check the simulation of it, right? information, right? So I have already said you, right? So we have to give different inputs and check for it. Our clock and reset bit. So in here, okay, let me just expand this. So J and K, right? So if J and K is 0, then whatever the previous state, that would be retained here, no change state, right? So if it is 0 1, it is 0 1, so that is the reset state. If it is 1 0, it is 1 0, that is set state. Similarly 1 1, in the sense it will be the toggle state here.